So we're going to talk about special parallelograms. There are 4 in particular that we're going to talk about. The parallelogram, of course, is not a special parallelogram, but we're going to include it because it's what we're going to compare the other shapes to. So we're going to start off by talking about the properties of a parallelogram, which you should be familiar with. And then we're going to introduce 3 types of special parallelograms. So what that means is that the other 3 you see listed here, rectangle, rhombus, and square, those are parallelograms. A rectangle, a rhombus, and a square are all types of parallelograms, but they're sort of like parallelogram plus. So they have all the characteristics of a parallelogram plus some more characteristics. So let's start off by talking about the characteristics of a parallelogram. So a parallelogram is, first of all, it's a shape that has 4 sides. But I can't just draw a shape with any 4 sides that I want to, because, for example, if I were to draw this, 1, 2, 3, 4, that has 4 sides, but is certainly not a parallelogram. It's a quadrilateral, not a parallelogram. For something to be a parallelogram, it has to do a few things. So here's a picture of what a parallelogram might look like. So the first thing to know about parallelograms is that the opposite sides of a parallelogram are parallel. The symbol that we use for parallel are the arrows. We call these diddly-doos, I believe is the official math term. So those 2 are parallel, and these 2 are parallel. I'm using double arrows on the top and bottom because obviously the top and bottom are not parallel to the left and right. So that's all a parallelogram is. A parallelogram is a quadrilateral, meaning it has 4 sides, and the opposite sides are parallel. When this happens, though, we get a few little properties of parallelograms. So let's talk about those properties of parallelograms. When you have this shape, what else happens? Well, not only are the opposite sides parallel, opposite sides are also congruent. So this side is congruent to this side, and this side is congruent to this side. We also know that opposite angles are congruent. Meaning this angle is congruent to this angle, and this angle is congruent to that angle. We also know that, let me pick a really pretty green color here. My son's diaper looked like this morning. We also know that diagonals bisect each other. Meaning, if I were to draw in a couple of diagonals here, that the diagonals are cut exactly in half. So this piece and this piece are congruent, and this piece and this piece are congruent. If I was a really good mathematician, I would do 3 lines and 4 lines on those to show that they are not congruent to the outside edges. In fact, let's just go ahead and do that. Let's go ahead and be good mathematicians. We'll try something new and be good mathematicians. And finally, the last thing we know, let's use this really pretty light blue color. Consecutive angles are supplementary. So if I were to label these angles, M, N, L, and O, consecutive angles being supplementary means if I add any two angles that are next to each other, so like angle M and N, for example, are consecutive angles, M and N, I could say that the measure of angle M plus the measure of angle N is 180 degrees. This is true of all four pairs. So that was the top two angles. I could also do the measure of angle L plus the measure of angle O is 180 degrees. And I could say the same thing about the pairs of angles on either side. So the measure of angle M plus the measure of angle L is 180 degrees. And I could also say that the measure of angle N plus the measure of angle O is 180 degrees. And I know I wrote that pretty quick, so I'm going to pause for a minute for you to catch up while I do some really pretty highlighting here. So that's a lot of stuff about a parallelogram. From such a simple shape, it's just a quadrilateral with parallel sides, we're able to get a whole lot of properties of that parallelogram. And since our special parallelograms, the rectangle, rhombus, and square, are parallelograms, that means these properties also apply to the rectangle, the rhombus, and the square. So in a rectangle, the consecutive angles are supplementary. The diagonals bisect each other. In a rhombus, the opposite angles are congruent. In a square, the opposite sides are congruent. All of these properties apply to all four of these shapes because the other three are parallelograms. So the parallelogram is the shape that we're going to write the most for. This has the most properties. We're not going to rewrite these properties. We're just going to kind of mentally copy and paste them onto all of the other types of shapes. Let's move on to a rectangle. Now, who knows what makes a parallelogram become a rectangle? It has to have opposite sides parallel because it's parallelogram. But what makes it go from being a parallelogram to being a rectangle? Very good. Emily says 90-degree angles, and she is exactly right. Peyton says straight lines, which is also true, but a parallelogram has to have straight lines. What allows our parallelogram to promote from parallelogram to rectangle? A rectangle is a parallelogram with four right angles. So let's go ahead and draw a picture of our rectangle. And it must have four right angles. A rectangle is a parallelogram with four right angles. And remember, kids, if it is not a right angle, it is a wrong angle. That's how I organize everything in my house. I'm very type A. It's not a right angle, it's a wrong angle. When I put the TV remote on the coffee table, the TV remote and the edge of the coffee table must be parallel. It just makes sense. Forms a really nice 90-degree angle right there at the corner. That's a pretty funny message. That's just sad. There's nothing sad about order. Like I put the TV remote on one side of the coffee table, and then I put like, we have Apple TV, so I put the Apple TV remote on the other side of the coffee table so that it's balanced, perfectly balanced, as all things should be. Hashtag Thanos did nothing wrong. So there are two rectangle theorems that we're going to jot down real quick. And the first one's called the rectangle angle theorem. Yeah, Peyton, honestly, I think you're the one with the problem here. The rectangle angle theorem says a parallelogram is a rectangle if it has one right angle. So the reason why this theorem works is because if we know it's a parallelogram, we know the consecutive angles are supplementary. So if one angle's 90, the two consecutive angles next to it have to also be 90 so that they're supplementary, which gives you three 90-degree angles. And a quadrilateral always has a total of 360 degrees. So if we've got three 90-degree angles, the fourth one has to also be a 90-degree angle. So in order for something to be a rectangle, it must have four right angles. But if we know that the shape is a parallelogram, just knowing that one angle is right tells us that the entire set of angles must all be right. A similar theorem is the rectangle diagonal theorem. The rectangle diagonal theorem says a parallelogram is a rectangle if its diagonals are congruent. I'm going to have to move my square here. A parallelogram is a rectangle if and only if its diagonals are congruent. And we'll do a proof of that in just a little bit after we talk about the rhombus and the square. Because I know you guys are missing proofs. I know you're thinking to yourself, man, we haven't done proofs in a long time and I miss them. I feel you. I miss them too. I see proofs everywhere, in the laugh of every child, in the smile of every baby. Okay, let's talk about a rhombus. What allows our parallelogram to promote to the rank of rhombus? Does anybody know? Anybody know what makes something a rhombus? Very good, Emily. Emily says all four sides must be equal, and I'm assuming that what she meant to say was congruent. A rhombus has four congruent sides. My daughter loves to play in shipping boxes. Like if we get a box from Amazon that's like unusually large, like if we get a dog food delivered from Amazon in a big box, she likes to take all the stuff out and then she sits in the box and says it's a spaceship. She puts stickers of stars and stuff on the side, and like draws little spaceship controls, and she sits in the middle of the living room in the box and pretends like she's flying a spaceship. She when we got a new stove a few months ago, and that stove box, oh my gosh, the guys who delivered it were like, oh, we'll take this box for you and throw it away. And Audrey was like, no, that's my new house. So she like drew a door on there and like cut out a window and just played in that box until it fell apart. And so she told me that I could come stay in her box house. And so she laid it over on its side. So like the opening was on the side. And I crawled into her little box house, and she had like pillows and stuff in there so you could take a nap in the box house. And I was like, oh, this box is so cozy. Well, I should have known when she offered to share her box house that she was up to no good. Because after I'd been in the box house for about 30 seconds, all of a sudden, I realized that Audrey had climbed up on the couch and had taken a flying leap off the couch onto the top of the box house while I was in there. She was trying to squish me. She thought it'd be really funny. But it's a pretty sturdy box. It had to hold an oven. It's pretty thick cardboard. And so when she jumped, I think she thought that the box was just going to like cave in and she was going to land on me. But what actually happened was she hit the top, and the box sort of bent over to the side, like it was this shape right here, and then it kind of bent over and she slid off the top. So the joke was on her. The point of my story is that is what a rhombus is. Imagine that square opening on that box. And she jumps on top of the box and it leans over to the side like that. She's not quite heavy enough to flatten it, so it just bends to the side. When it bends to the side, that is a rhombus. So a rhombus is like a square that somebody sat on so that it leans over to the side. Not sat on it like they squished it, because if they sat on it and squished it, it'd be more like a rectangle. But somebody takes a flying leap on top of that square box and it slides over to the side, like bends over under their weight. That's what a rhombus is. It's a square that somebody sat on. So it's very, very close to being a square. As a matter of fact, there's only one thing we have to add to this to make it a square. Okay, so Peyton asks, how do you describe a parallelogram? A parallelogram would be if instead of the opening on the box being on the bottom, if the opening was on the side, so that the side was a rectangle instead of a square, and then somebody jumped on it. So if the opening's a square and somebody jumps on it, then the opening becomes a rhombus. If the opening is a rectangle and somebody jumps on it, then the opening is a parallelogram. It's also, if you have two lelograms, then you got parallelograms. Where's Ellie when I need her? Okay, so here's the theorem we're going to go for with the rhombus. It's called the rhombus angle bisector theorem. The rhombus angle bisector theorem is another way that you can identify a parallelogram as being a rhombus. A parallelogram is a rhombus if and only if its diagonals, both diagonals, bisect the angles. So a parallelogram is a rhombus if and only if each of its diagonals bisects two of its angles. And I'll draw a picture of what that looks like because I think the picture maybe is more useful than the words. So write that definition, and then we're going to draw a rhombus. And I'm going to go ahead and put some diagonals in my rhombus. If it bisects the angles, meaning if that angle and that angle are equal, and this angle and that angle are equal, then it is a rhombus. If the diagonals bisect the angles. Another important theorem of the rhombus is the rhombus diagonal theorem. This one's a little easier. It's a little easier to wrap your head around, the rhombus diagonal theorem, which states a parallelogram is a rhombus if and only if its diagonals are perpendicular. It's important to note that unlike the rectangle, the diagonals in a rhombus are not congruent with one another. In a rectangle, the diagonals were congruent. In a rhombus, they don't have to be. But they are perpendicular. Now, what's really going to bake your noodle is that since rhombus bisects the diagonals, the diagonals bisect each other, and all of the sides are the same, that means this, 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 and this are all congruent, and this are congruent, and this are congruent. That means by the side postulate, all four triangles formed by the diagonals are congruent. And that is cool. Just in case you thought triangle congruency was going anywhere, surprise, it's back. So a rhombus has, well, first of all, they are parallelograms. Obviously, four congruent sides. Diagonals are angle bisectors. and perpendicular diagonals. So they have all the properties of a parallelogram plus those three things. I suppose in the interest of completeness, we could go back up to your rectangles here and do the properties as well, since we missed out on those. A rectangle is a parallelogram that has 4 right angles and congruent. I don't know why I'm writing the word congruent like an animal. Congruent diagonals, just so we get the whole thing. Square time. Did you guys do square dancing in elementary school, or was that just my generation? Did y'all have to do square dancing? Yeah, that's rough. It was terrible. Could there be a more useless form of dancing to teach people? Like outside of elementary school, or maybe like if you're doing a barn raising with your neighbor Jedediah, when are you ever gonna square dance? It never comes up. And you know what? Not one elementary school kid ever asks, when are we going to use this in real life? Because elementary schoolers aren't jerks like high schoolers aren't. When are we going to use this in real life? Well, kids, if you ever want to join the commune, you're going to have to square dance. Okay, squares. I don't dance, period. Sometimes you can't help it. Sometimes, as the great Gloria Estefan said, the rhythm is going to get you. Okay, here's the squares. A square is intense. A square is a rectangle and a rhombus. So a square is a parallelogram, so it has all the properties of a parallelogram. It's a rectangle, so it has all the properties of a rectangle, and it is a rhombus, so it has all the properties of a rhombus. So let's take these piece by piece. So if a square is a rectangle, that means it's got 4 right angles. It's a rhombus, so its opposite sides are congruent, or all of its sides are congruent. Its diagonals are perpendicular angle bisectors. All right, sharpen your pencils, kids. Here come the properties of a square. They're parallelograms. They have 4 right angles. They have congruent diagonals. They have 4 congruent sides, just like a rhombus. Their diagonals are angle bisectors. And their diagonals are perpendicular. Give you just a minute to catch up there. One week ago, I was huddled under 17 blankets trying not to die. And today that I got the fans on. Texas, man. Texas. Do I know how to square dance? I can do-si-do and promenade like you wouldn't believe. I can bow to my partner and to my corner. You know what? I'm used to people hating on my 6 square dancing skills. It's fine. Okay, now I did promise you a proof, so let's do that. I would hate for you to think that I'm not a man of my word. We're going to prove the rectangle angle theorem. I'm going to give you a parallelogram called QTRS. So, QTRS, like so. Because it is a parallelogram, I can go ahead and put my diddly-doos on here. Parallelogram means opposite sides are parallel. And we're going to go ahead and say also that one of these angles, we'll say angle T, the measure of angle T, is 90 degrees. What the rectangle angle theorem says is, if you have a parallelogram with one 90-degree angle, that means all the angles are 90 degrees. It's a rectangle. A parallelogram with one 90-degree angle is a rectangle. So that's what we want to prove. We want to prove that QTRS is a rectangle. Okay, so let's go ahead and do our 2-column proof. You could do a paragraph proof or a flow proof if you wanted to, but I like 2-column. Call me old school. with any proof we ever do, ever, the first step is always what? The given. We were given two pieces of information, that QTRS is a parallelogram and that angle T is 90 degrees. Some people will just put the entire given all in the first statement, and some will divide it up into two statements, like number one, it's a parallelogram. Number two, angle T is 90. I don't care which way you do it when you're writing it out. I'm just saying whenever you're doing your assignment, the given may be all in one line or it may be in two separate lines. It doesn't matter. I'm going to do economy here, save some digital ink and put them all in one step. So I'm going to say QTRS is a parallelogram. I don't want my digital pencil to run out of digital ink. So I'm going to write this all in one step so that I only have to write the word given one time. That's just economical. Okay, so all we know is that it's a parallelogram. What properties of a parallelogram are going to help us figure out that this is a rectangle? Keep in mind, to prove that it is a rectangle, we have to show all four angles are 90 degrees. So we need to show that Q, S, and R are also 90 degrees using only the properties of a parallelogram. So I'm going to go back up to my parallelogram here and see if there's anything useful here. And one of the things I see that's useful is right here, opposite angles are congruent. Opposite angles are congruent seems useful because if I know that angle T is 90 degrees, what other angle do I know? Oh, Emily's saying consecutive angles are supplementary. I could have done that. In fact, I am going to do that one here in just a minute. You could do that one first. It doesn't matter. But if I use the opposite angles are congruent, what angle do I know? S. So what I know is that they are congruent, and this is a little weird the way that you do this in a proof. I know they're congruent. I don't know that they're equal. I'll show you what I mean. So step number two, I'm going to say that angle T is congruent to angle S. And the reason I know that is opposite angles of a parallelogram are congruent. So opposite angles of a parallelogram. I wish there was an abbreviation for parallelogram. I don't know how you could, you'd have to do parallelo, because if you just did parallel, that's a different thing. So I know they're congruent. The way that I know they're equal is because that's what congruent means. So step three is going to be the measure of angle T equals the measure of angle S because definition of congruent. I know that seems like a weird thing. But the reason I have to set it up like that as an equation instead of a congruency statement is because of what I'm going to do next. Angle T was 90 degrees. That means angle S is also 90 degrees because they're equal to one another. What is the reason I'm going to use for why angle S is 90 degrees? Transitive or supplementary? Transitive's a pretty good guess. But the thing I'm looking for is starts with the same sound as supplementary. transitive's not bad. I don't think anybody would throw garbage at you if you said transitive. I mean, they might throw garbage at you for other reasons, but not because you said transitive. Okay, so we figured out 2 of our angles are 90 degrees. Hey, we're halfway there. So let's talk about what Emily said. She said another property of parallelograms is that the consecutive angles are supplementary. I just figured out angle S is 90 degrees. So let's look at, I mean, I could do Q or R, it doesn't matter. Let's just do R just because. So I know that the measure of angle R plus the measure of angle S should be 180 degrees. And the reason I know that is because, as Emily just said, consecutive angles of a parallelogram are supplementary angles. This seems like a good time to do substitution with that step, with step 5, the measure of angle R plus 90 degrees, because angle S, we just figured out it's 90 degrees, equals 180 by substitution. And now it's pretty simple to solve this for angle R. Do you know what the property is that allows me to solve for angle R? I mean, obviously angle R is 90, but do you know what the property is? What is the property? How did I go from step 6 to step 7? What did I do? Talk amongst yourselves. I'll give you a topic. Actor Rafe Fiennes' name is spelled neither Rafe nor Fiennes. Discuss. I'm getting all verklempt. I subtracted, thank you. So it's the subtraction property. I knew if I busted out the stereotypical Jewish mom voice that you guys would suddenly have a moment of inspiration. Okay, so we figured out 3 of our angles. We were given angle T. We just solved for angle S and then angle R. There's only one left, and that's angle Q. And there are 2 different ways we can do it. We can do exactly what we just did with the consecutive angles thing, except instead of R and S, we could do Q and S. That would be fine. Or we could do what we did to solve for angle S in step 4, which is that we could say the opposite angles are congruent and use the definition of congruent. I think those are going to require the same number of steps from me, like the same amount of writing. So flip a coin, pick your favorite. I'm gonna do the opposite angles are congruent. So angle R is congruent to angle Q because opposite angles of parallelograms are congruent. I'm just following, I'm copying exactly steps 2, 3, and 4, except with angle Q. Okay, so the next step would be the measure of angle R equals the measure of angle Q, because definition of congruent. Which means, by the substitution property, angle Q is 90 degrees. Okay, now we have proven the last thing that we needed to prove, that you needed to prove. I don't got to prove nothing to nobody. We proved that all 4 of these are right angles. How do we know they're right angles? Again, this is a little silly proof thing. How do we know they're right angles? Because they're 90 degrees, and that's how big right angles are. So we're going to say angle Q, angle R, angle S, and angle T are right angles. How do we know that? Because the definition of right angle says if it's 90 degrees, it's a right angle. The definition says that, and also because I said so. So we now know it's a rectangle because it's a parallelogram, which we were given, and it's got 4 right angles, which makes it a rectangle. Definition of rectangle. Yes. Are we done with this proof? Well, did we prove the thing that we wanted to prove? We wanted to prove QTRS is a rectangle. And the last thing we wrote was QTRS is a rectangle. I think we're done with this proof. You want to keep going? Let's talk about the diagonals. Let's prove that if you draw a diagonal to create 2 triangles, that those triangles are congruent by side, side, side. How about no? You gonna prove one of the rhombus theorems? What was the, no. The proof where you have to show that if the diagonals are angle bisectors, then it is a rhombus. That proof I think is even longer than this one. I think that proof is like 15 steps long or something. We can do that one though. I like proofs. I will prove to you that they are fun to do. Huh? Huh? Okay. Does anybody have any questions other than, will you please send me the notes because I didn't get all of that? Answer, yes. Matter of fact, I will do that right now.